that will take these statements in C or any other language and convert it into a language that the machine can understand and carry out the task. Right? Those are called in C is a compiler, and in other languages like PHP it is an interpreter. They take, now the difference between a compiler and an interpreter is basically the compiler will convert the entire program in one go to machine language, whereas the interpreter will go line by line and start executing line by line. So let's take a look at the language called C. So this, can you see my slide?
Yes, sir.
Yeah, okay. Now this is the basic, very simple C program. And there are different parts that you have to understand in this program. So I will explain to you the basic parts of a program, a C program that you want to, when you are writing. Now there's a statement called include. Now that statement is a statement that we put in our C program, right? When we want to use some library. A library is a set of instructions that that has been written previously, and where some of these instructions we use in our program. Now, for example, stdios, which stand for standard input output, is needed because that is where we get this printf statement, right? That is where we get this printf statement. So we include, that is, there's a hash sign, then the include, and the name of the library within these angle brackets. So what happens when we compile this program? Before compiling the program, what the compiler will do is, it will bring in these libraries into your program. You don't have to do anything. You just have to say, okay, I want to use these libraries. So it will automatically bring these libraries before compiling the program. So in our program, if I go and say printf, that function will already be included in our program, because we have said, okay, bring me this library, include stdio, just bring it here, right? Okay. Then also, okay, that is the first statement. Then any C program will have what is known as this main, right? Main is the key entry point. When we are running the program, it will first go to the main and start running the instruction within the main, right? So it is a very important statement. Int main. We will look at what this int means in a moment. And then we write a block of statements here. This set of statements is what is inside this main. And to indicate the beginning and the end of these statements, we use what is known as the curly bracket. Now it starts here, the beginning curly bracket, the ending curly bracket is here. That is how we identify a block of statements, the set of statements that we have to run as in one go. Okay? So the main function is this, and within that, there's a block of statement. Right? This is the start, beginning curly bracket, and ending curly bracket. That is also required. Then we come to what it says here, a comment. Now comments are very important. The compiler has nothing to do with the comment. Compiler doesn't do anything with the comments. Compiler forgets about the comments because it's not required for them. It is for us humans, because we humans, we tend to sometimes forget what we have done. We write a program, we use many algorithms, etc. But eventually we forget, okay, in 2 years you come and look at the same program, you don't know what I have done. So what we do is, you write statements to understand your code. And the other thing is now nowadays a single person will not write a program. It's a team. So when you are writing one part of it, you want to allow others to understand what you have done. So you put comments here, right? Then comes the only thing that this program does is print hello world. It writes these words hello world in your screen, and this \n means a new line, that is it will print hello world, and then it goes to the next line. Then finally it does this thing called return 0. That is, it says, okay, the 0 it generally means, okay, it worked without a problem. If there's an error, you would return a different number than 0. So whoever who called the program, if he gets a 0, he knows, okay, I mean, this worked well. Otherwise, you can return a code, right? Now, this 0 is the one that matches to this, what we call the int, right? So the return is that it will send this value back to whoever called the program. Okay. Any questions on this part now? Because this is a very important thing to understand. Anybody has any questions? You can either ask me or. Okay.
So, do you recommend any specific IDEs for C program?
Okay, we have been using I think code blocks.
Yeah.
A thing called code blocks.
Okay,
and also, Neil, do we have the virtual lab as well in this course?
Yes, virtual lab is also there.
Is it available to the students?
Yes, yes. Some
Okay.
examples are also there.
Not examples. I mean, can they start writing programs in the code?
Yes. They
Virtual
can.
lab.
Yes.
So, do the students have access to the course?
Yes. Now it is all the students can access.
Okay. So, I mean, if you go to your Moodle, the Open Learn Moodle site, you will be able to access the thing. Then there is a, according to Mr. Herat, who is coordinating this program, there's a virtual lab where you can write your programs. If not, you can use something called the code blocks. The instructions are also given there in the your Moodle course 3417. Right? Any other questions? Okay, somebody told me to go full screen. Okay, let me see. Okay. It is okay now. Whoever put the comment, full screen. Lochini.
Okay, sir. Thank you, sir.
Okay. Okay. Right. So, any other questions on the basic structure of a C program? Okay. I mean, if you have any questions, you can type into the chat box. So I'll once in a while I'll read and try to answer. Okay. So now let's take a look at what goes inside this program. Inside the C program, different parts that can go there. The very first thing that we are going to look at is the type of data that we can handle. Right? Type of data. Now, within the C program, there are many different data types. Some are basic data types that are part of the basic C program, basic C programming language. Then you can also define your own data structures that you will learn later. Right? So when you look at data type, we can have numbers. Basic data types include numbers, then characters. That is, characters means anything that like letters, numbers, other special characters like hash, percentage sign, etc. or even, Sinhala characters, Tamil characters, any characters. Those are, that's a different data type for character. Then we have numbers. The numbers can be again broken down into two types. So, one type of numbers are integers. That's a whole numbers, like 1, 2, 3, 4, things like that. Then we have decimal numbers, that is 29.56. Some of our numbers are integers, some of our numbers are decimal. If I ask, how many students in this course, let me see, we have 195. We will never say we have 195.25 students in the class. So that's the integer. But if I ask your marks, your average mark, that could be a decimal number. So we have different types of keywords to represent these different types of numbers. Right? Like, for example, we have byte, we have short, and one of the most used data types is called int, integer. Then for decimal, we have types like double and float. And characters will be char. Right? Now, these are the data types that we have. Now we want to store values inside the computer. I mean, the whole purpose of a computer is to process some data. Now we have to store that data inside the computer. Right? Now, if you look at the previous program, we did not use record any store any data. We just went into the program, we printed this value, hello world, and we return. That means we ended the program. Right? So we need the concept of a variable. Now, what do you understand by a variable? When you say not in programming, something is variable. Do you know anything that is variable in your life? You can type into the chat box if you want, or you can say, you can unmute and say.
Changing.
Changing things. Variable means changing. Now, for example, if you look at the foreign exchange rate, now it is a variable. It can change, right? Today it can be one thing, tomorrow it can be one thing. The cost of a loaf of bread can change from today to tomorrow, or the gas, or the petrol, or all these things change. So inside the programming language, we call a variable to values that can be changed. Now, how do we do that? Now, when we where do we store values in data in our program? In something called memory locations. Inside the computer, there is memory, and it is in this memory we store our values, record our values. Right? Now, one thing is, now this inside the computer, these places where we record values, the memory locations have numbers. They are numbered, one from 0 up to billions. But we as humans, we are not good at recording these numbers. So all these programming languages allow us to give it a name. You remember, I don't know whether you will remember, but those old days, even our houses had names. There's a number to the house, but we used to give them names, Daisy Villa, Carlton House, like that. Now, similarly, inside the programming also, it allows us to give a name to this location where we are storing the value. Right? Right. Sorry about that. So this location, this is where we put the value, and we can give it a name. We can give it a name, and we can refer to this value using this name. And this name, we call it a variable. Right? Now, using this name, I can either find out what this value this variable refers to, in this case 24, or I can change this and put another value. Right? So that is what the concept of a variable is. Now, like I said, a variable is a location and the value can be changed, and the values have to have data type, the type of data, because depending on the data type, the number of memory locations that is used to store this value will be different. Now, for example, byte will take only 1 byte. 1 byte is, 8 bits. 1 bit is a single 0 and 1. And with 8 bits, I can store a byte. Then, depending on the compiler, the short and int might use, 2 bytes or 4 bytes or 8 bytes, depending on the type of the machine. But it doesn't matter to us, because when we say use the data type, it will automatically allocate that kind of memory, that amount of memory, and put the value there and give us a name to use. For example, now how do we declare variables? You have to put the data type, then the variable name, and optionally we can assign a value as well. Now, for example, here, I am declaring a variable of type int. So depending on the number of memory locations, 1 byte or 2 bytes or 8 bytes, what the machine uses, it will allocate that amount of memory and give it a name, mark 1. Now, whenever I refer to mark 1, it will be referring to the value that is inside that box. Right? In this one also, I am defining another variable called mark 2. And here, I can do this also. If I have multiple integer type variables, I can say mark 1, then mark 2, and I can assign a value to mark 1 as mark 2 as well. Then another variable called mark 3. Right? I can do it in single line as well when you have multiple variables of the same type. Right? Then if it's a char, I can say char flag x. Okay. Right. So this is how we declare variable. Now, for example, this is some example. Now I declare a variable called age here. Int age. I'm saying this age should is a name that I am using to refer to the values stored in this box. This box can be of any size depending on the machine. Usually it will be about 4 bytes. Right? Then I use the equal operator. This operator called equal. Right? To assign values. Now, when I say in mathematics, if I say x equals 5, what does it mean? What does it mean? Can somebody tell me? In maths, you have used this, no?
We assign the value 5 to x.
Is it? Is it assigning? In mathematics, when you say x equals 5, what does it mean? In maths, I'm saying normal maths.
It confirms value of x is 5.
I'm saying value of x is 5. Right? So in programming, I'm using this operator. So I can take the value 25 and put it into this box named age. That is what this statement is saying. Take the value 25 and put that in a box called age, or memory location named as age. Right? So similarly, I can put char type variables. Then we have something called bool, which is a true or false type variables. And the equal sign always means put that whatever is in your right hand side into the left hand side name. Now in programming, what would this mean? In math, what do you think? Are these two statements the same or not? In normal mathematics, there's a statement here. There's a statement here. Are they the same?
Same.
Same. But in programming, this is wrong. Why is it wrong? Because this equal sign means take x and put it into 5. We can't put a value into 5. Value of 5 is already defined. So always it will be a variable on your left hand side and a value in your right hand side. That value can be other variables also. Okay. Right. So that is how we define variables. Right. Then this is a program that I am that uses variables. Okay. Here I have included my standard input output library because I needed to use this printf statement. If I don't need the to print anything, I can forget about the standard input output library. It will work. Now here I am looking some variables. I am declaring some variable. Okay, I have the this should, let me not complicate this. Just give me 1 second. Let me change this to int. Right. Now here I have int main, the main program. This is what I'm going to run. Then I have start bracket and the end bracket. Now many IDEs, when you put a start bracket, it will put the end bracket as well. So you can write whatever you want inside the program. And then here I am declaring a variable called work days, and I am saying it's a 5. Either you work on a particular day or you don't work. There cannot be half days work. And number of hours per day. I'm saying, okay, if you are a worker, you have to work 8.5 hours a day. Then the pay rate, right? The hourly rate for pay. Then the weekly pay would be number of days you have worked and number of hours per day and the rate per hour. And then here I am printing that value. Now I want to explain something to you here. Now in our previous program, we just had the just a printf statement, hello world. Remember? Right. Let me. I can, in our previous program, I had something like this. Right? I had this statement. Printf hello world and a backslash n and this. Right? Now here this is something different. You can see it's something different. Now the person who wrote to me. Lochini, can you see the screen?
Yes, sir. Yes, sir.
Is this size okay?
Okay. It's okay, sir.
Okay, good. Right. So because I need to type here, otherwise I can't type. Right. So okay. Right. Now here it's slightly different. Now here I have the quotation mark like this one. Here I have the quotation mark. That means that it is a string. I write weekly pay and RS. Then there is this special character. Okay. There is this special character, which is this one, percentage sign F. Now, in a printf statement, we will talk about this. This is known as a format specifier. That means I am telling the computer, okay, print this part. This weekly pay, write it as it is, equal rs dot, all that put. Then you have to put the value of a variable. And that variable is a floating point value. That is a decimal value that has a decimal component. And I'm not saying what that, where that value is. That value comes here. Right? So here I am saying you have to print this, and then you have to print a value. That value is given here. Right? So that is what this print statement is doing. Right? So that is a use of variables in a program. Right? Okay. Some of you have never written a C program. Let me see whether I can get my Neil, where would I find the Neil, are you there?
Yes, sir. But
Where would I find the virtual programming lab here?
in LMS, no?
Yes.
LMS in what is this? Self-learning, under self-learning. Under self.
Okay, let me
No. Under the lab 2.
huh?
Under the lab 2.
Lab 2.
Yes, there are examples.
No, not the examples. I mean, can I run a program there?
Yes, yes. So those examples we can run. Example 1, we can choose exercise 2. Exercise 2.
I can't log into this thing. Okay. Lab 2.
Yes.
Lab 2 practicals, example 1. Okay. Right. Let me share this. Let me stop sharing this, and let me share the virtual lab. Can you see my screen? Virtual lab.
So it is better. The next one.
Huh?
It is better to take exercise 2.
No, it's okay. I'll just write this.
Okay.
But can you see my screen?
Yes,
Yes, sir.
Okay. Now this is a tool that is available to you if you go to the course, right? Under lab 2. This is your course. You know the course on software development for engineers. This course. And if you go to lab 2, now there are all these sessions, etc., that is available to you. And there's something called lab 2. If you go to lab 2, there are some examples of programs written here, right? So let me just go there, because I'm not going to use the example, but I'm just going to write a small program. In this program, I'm going to write it there. So this is the screen that you will see. New file name, I will say EEX3417 example1.c. Remember that you have to put here .c for it to work. And those who have access, you can actually go and okay, I'll type the link here. Also, you can go and try it out if you want. Right. So I'm going to get my program that I have written, and I'm going to put it here, and I'm going to run it. Okay. Give me 1 second. Right. So I'm going to put my program here. This is the program that we have written. Can you see this? It's the letters are very small, but can you see it? Hello.
Yes, sir.
Okay. So this is a program that we tested. So I type my program here. Then I am saving the program here. Once I save, it will allow me to run this program. So I'm running it, and it produces this value. Right? It says weekly pay is this much. So you can see that it now if I change the text, and now I have to save it again, and I can run it. You can see that the text change, but the same value comes. Right? So you can also try using this what you call the virtual programming lab, and type your programs. Anyway, when you are doing the labs, you will be using this to lab evaluations. You will be using this to submit your work. So we can give you a mark. Right. Okay. Right. Okay. So let's go back to our session. Okay. So we saw that this program works. The same program as it is, it works. And now we talked about variables. Now variables are values that can change. But in some programs, we have values that does not change. Now, for example, the value of 5, right, is a constant. It never changes. Right? Or let's say the minimum age for driving is 18. Unless the parliament decides that, okay, the minimum age can be 16, it remains a constant. So some of these values are constant. Now, for example, if you have a program that we are asking some user to enter the age, we can say, okay, a person who is a reasonable value for the maximum age is 140. I mean, there have been cases, where they say that there are 2000-year-old persons, but that is not a normal case. So in a normal case, a human, generally a maximum age is about 120. So we can give another 20 years and say maximum age of a living person can only be 140. Right? The minimum age for something is 80. The value of 5 never changes. It's 3.14, and it's a indefinite number. Right? Like that, we can define constant. So there are two ways we can define constants. One is like this. We can use this. Here I can use this keyword define, or that is a pre-compiler directive that will be defined before the program is compiled. So after that, the maximum age will always be 140. Or within a program, like when you are declaring variable like int minimum age, I can put a keyword called const in front of that to say that this value is a, you store it in the as a normal variable place, but the value will not change. Right? We can do that. Right. So those are constants. Now, the library, the standard input-output library has several input-output statements that you will need. Right? Now, on your left-hand side is the input statement. Now, getChar is to read a value, right? Get a value. GetString is to get a string, read a string, and Scanf is to read different types of values using this statement. So we will see how we can use Scanf. And to output, you have basically printf statements, and then you have similar to getChar, you have also putChar, putString, and even in a printf statement, you can put these values. Right? And I said that previously, I said that these characters here, they are known as, what is this? Right? These characters, percentage %s and %d, they are known as format specifiers. That tells what kind of values are going to come after that. Right? Now, in a printf statement, also we can use this here. You can see %s and %d. That means s means okay, you have to print a string, and then d means put a integer value. You are going to print an integer value, and those two values are given in these variables. Right? In these variables, you can see the values. So the first one is a string, second value is a integer. str is a string, I is a integer. Now scanf also, I can use the same notation and say here this is a percentage s means read a string, and percentage d means read the integer value. The scanf means read the value from the keyboard or basic input device, which is generally the keyboard. And I have the str here, right? But when I'm reading an integer, I have to put an ampersand sign. This sign, ampersand, right? The ampersand sign. Why do you have to do that? Because the scanf will actually put the value in the memory location of this variable. So we have to give him the scanf what the memory location is. That is why we are putting ampersand sign here. But the str is a different way that it is represented. str will always contain a memory address. The value is a memory address, and it handles it separately. So if you are using integers, floats, etc., you have to use the ampersand. Otherwise, strings you can use just the variable name when you are reading values. Okay. Is that clear? Do you have any questions on that? Are we clear on what we have done so far? Anybody who is not clear, can you raise your hands? Or the other way, those who are clear, can you raise your hands? One person is okay. Only one person understand the class. Two people. Oh. Okay. I've got like a few. Okay. So if you don't understand, please ask. You know, I don't mind. Out of this thing, 22 raised their hands. So out of 210, 22, 10% understand
Excuse me,
what I'm
sir.
saying. 90%
Excuse me,
do
sir.
not understand what I'm saying. So okay, it's a problem.
Excuse me, sir.
Yeah.
Sir, can you explain again scanf command part?
Okay. Okay. I'll do that. Let me put a new slide. Okay. Now the scanf works like this. Scanf, right? And you have to put the format specifier. What kind of values you are reading within the the quotes character, right? Now, if I am reading a string value, I say, okay, I want to read a string value. If I am reading a integer value, I say, okay, read the integer value. If I want to read the floating point value, decimal value, I say a floating point value. Then the way that the computer, the C language stored strings are, it is actually str variable contains a memory location, right? So I don't have to put that. But other variables, now for example, if I'm looking to read age, I can't give the variable name. This ampersand means it is the location of variable age. To scanf, I have to give the location where this variable is located. And how do I find the location where age is stored? I put the ampersand sign before it. Then it finds a location. Now this ampersand age means location of where that age variable is. To scanf, we also always have to give the location. But when it's a string, the string variable, how it works inside C is, it already contains the location. Right? So I don't have to put the ampersand there. But other values, I have to put an ampersand. Age, say salary. So when I do this, what it will do is, the first one, it will read a string. The second, it will read it as an integer. Third value that I'm giving from the keyboard, it will read it as a floating point value. Right? Does that make it clear now? The person who asked the question.
Okay, sir. Okay, sir.
Yeah. Okay. Great. So okay, let's go to our program and see how this works. Okay, it's the same program that we have here, the one that I wrote a little while ago. You can see my screen, right?
Yes, sir.
Hello? You can see my program, right?
Yeah.
Okay, let's say that I don't know the number of days that person has worked. I'm going to read it from the screen, right? So I can put a little statement saying like this: how many days did you work in this week? Right? The number of days. So I'm going to read the number of days. And I can say scanf. Now this printf will print this message. Now in the scanf, I have to say, okay, what type of value do I have to read? I'm asking the number of days, that is also integer. So I will say read an integer value. And what integer value I put after the format specifier, I say, what was it called? Work days. And remember to put this ampersand sign, because this is a basic data type. I have to give the location. So now I can run this program, right? And here I have said work days is 5, but when I read the new work days here, it will replace that value, right? Right. So let me run this again. Here, now it prints this message. Can you see the message that I put? How many days did you work in this week? Now I have to give him a value. He's expecting a value. So I will say, okay, I worked only 1 day. Right? Then it calculates the rate of pay. That is 1250 into 8.5 into 1. Right? Now if I run it again, okay, let me change this value. It's 1200. I will change it to 200. Is 8.5 into, I will change it to say 6 hours, right? So we can see these changes. I'll say, okay, I work for 4 days. So it will be 4,800 because that is 200 into 6 into 4, right? 6 into 4 is 24 into 2 to 4,800, it says. So I can, this is how the scanf statement will work. So it's read the value work days for work days and stored it in the variable called work days, and that was used in later calculations. Right? Okay. Right. Okay. Right. So share. Let's go. Right. So these are scanf. These are the different formats. There are many format specifiers. You can go to the web. I mean, there are enough information about the format specifiers, etc. I mean, any programming language, you know, the web has a tremendous amount of information. So these are some of the format specifiers. If it's a character, you can say C. If it's a integer, you can say D. Floating value, you say F. If it's a string, you can say S, and other things. Right. So this is basic input and output. This is something that you will need: the printf statement and to print values, and scanf statement to read values. I mean, the most commonly used two input output statements. Are we clear on this, guys? Is it clear? Come on, can somebody answer, please?
Yes, sir.
Yes, sir.
Okay, good. Then let's continue. If you have questions, you let me know. Now in C, we also have what are known as operators. We already saw one operator, which is called the assignment operator. That is the equal sign. Then we have arithmetic operations. We have normal arithmetic operations, addition, subtraction. This is division, multiplication. This is known as a modulus operator. Then we have other operators like the relational operator. This double sign means checking for equality. If I say 3 double equal 4, this will be false because 3 is not equal to 4, right? But if I want to check a variable, whether the value of a variable, I can check with double equal sign means checking for equality. Then I can check for greater than. One value is greater than the other, greater than or equal, less than or equal, or I can check for not equal as well, which is the exclamation mark and the equal. Usually in C and many programming languages, exclamation mark is used as saying it's a negation, not, right? Then we have some logical operators as well. That is when we want to combine some relational operators. Now, for example, what are the conditions to be able to drive a car in Sri Lanka? What are the conditions? Can somebody type it in the chat box? What conditions has to be satisfied for somebody to drive a car in Sri Lanka? If anybody is willing to talk, yeah, please tell me, or type, at least type it in the chat box.
Age limit must be above 18.
Yeah, age must be above 18, and then
License need.
That
you have
should
to have a license. I mean, you should be able to drive a car and put a license. Otherwise, you can't drive a car, vehicle, right? Similarly, we have, I mean, to get the license, you have to have a physical condition, your eyesight should be good. There are many conditions that should be satisfied. So these logical operators we use when we want to say, but to do this thing, you must have this and this and this. Then we have something called the O operator, which is either you have this or this, right? Now, for example, if you want to follow a degree program at the Open University, either you must have 3 A-level passes, or what? What is the other way that you can follow a degree program at the Open University?
Foundation course from the
The
foundation.
foundation program. You must have passed the foundation courses. So if you satisfy either one of those conditions, you will be able to follow a degree program, right? Now, if you go to a conventional university, there's only one condition: you have to have A levels, and your ESET score must be greater than the cutoff ESET mark. And again, we have the NOT we have already talked about. Then in C, we have a special two operator that many languages have adopted this. The plus operator and minus operator. We will look at it in a moment. And then we have sometimes we have to operate at the bit level, right? You know, bits 1 and 1. We can say if it is an AND, this is 1. Bits 1 and 0. If it's an AND, it is 0, right? So bitwise operator sometimes you will need, and we have operators for that as well. Bitwise operators. We have worked on the at the bit level, right? So all these operators are available to you when you are writing C programs. So logical operators, we looked at this, the AND, double ampersand, both conditions has to be true for this condition to be true. This whole thing to be true. Both expression 1 and expression 2 must be true. But in the O, if either one of them is true, then the total condition will become true, right? And negation is, if you put a exclamation mark here, then it becomes, if the expression 1 is true, then with the exclamation mark it becomes false. If it is false, it becomes true, right? Right. Okay. Right. So how do we use these operators? Now, for example, here you can see, okay, we will be looking at this statement a little later, the if statement, right? But inside here there are conditions, right? You can see this is one condition. C, continuous assessment mark is greater than 40, and the final exam mark is greater than 40. That means you have passed. So for you to pass, both these must have to be true. The continuous assessment, I mean, in our OUSL, we have what is known as continuous assessment mark. You all will have to do this lab test and CAT's continuous assessment test. Then some subjects have assignments, some subject has mini projects. You have to pass all that to pass the exam, and also you have to pass the final exam as well, right? for you to pass the subject. So both these conditions have to be true. Unless both conditions are true, you will not pass the subject. Even if you get for the continuous assessment component 100, and if you can't get more than 40 marks for the final exam, then you fail. Or even if you get the final exam, you cram and study and get 100 marks for the final exam, but you didn't work during the semester and your continuous mark was 10, then again you fail. So both these have to be true for this to be, to consider that you have passed the subject. Right. So that is the use of the AND operator. Okay. Then these increment operators, when you say plus plus, it is very similar to this. Right? Say you have a variable age equals 35, and this year age is 35. Now, for example, banks, right? The banks have a special condition. If your age is above 60, you get a higher interest rate. Right? You get about, I think, 15% for 1.5 million or something. So age is, you say, is 59. Now let's say that next year you want to add 1 to this. So you can say age is equal to whatever is in age plus 1. Right? This is a very valid statement. I am saying take the value of age, add 1 to it, and put it back in the variable called age. Okay? Do you understand this? Hello?
Yes, sir.
Yes, sir.
Yes? Okay, good. Now this same statement I can use, I can write in a simpler way saying age plus plus. Right? These two are the very same. This statement and this statement are the same, because this age plus plus means add 1 to age, right? Add 1 to age. Now the same statement, the same operator plus plus can appear after the a variable or the before the variable, and when that happens, it has different way of working. Right? Now let's say that new age something like this. This statement. I have a new variable called new age, to which I put age plus 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 5. Now what happens here is, when I have the plus plus operator after the variable, the increment occurs before the variable value is, postfix is after the variable value is used. Now if age is 59, what will be the value of new age? It will occur after the variable value is used. So if it is 59, then it will use the value 59 and plus 5, it will become 64. But if I use this the same operator prefix, if I do this, right? So new age here, this will be, because I am using the existing value 59 plus 5 becomes 64. But in this case, what it will do is, when it sees the plus plus, it will automatically increase the value by 1 and use that new value in our program, in our operation. Now the decrement operation is also the same. Are we clear on this? Are we clear?
Yes, sir.
The
Yes,
plus
sir.
plus and plus
Yes,
plus
sir.
postfix and plus plus prefix, how they work? Anybody who does not understand, who is not clear, can you raise your hands if anybody is not clear? Okay, there are a few people who are not clear. Okay, let me say it again. The plus plus operator can go before the variable or after the variable. If it goes after the variable, what we are saying is, for this calculation, use whatever is the existing value, and after using the value, you increment it by 1. If it comes before the variable, what I'm saying is, okay, now increment the value of this variable by 1 and use the new value for the calculation. So that is why in this case new age will be 64. In this case, new age will be 65. Okay, right. So that is the increment and decrement operators. Then any programming language, you can use these statements, the processing statements. You can use these operators. All these operators you can use. So that is one part of the programming component. Then there are two other components that is present in many programming languages. There are programming languages that is not present, but most programming languages have what we know as selection structures and looping structures. Right? Now the selection structures are the conditional structures. That means we do something based on a particular condition. Right? Now if I go to the Department of Motor Traffic and I say, okay, can I have a license? The first question they will ask is, how old are you? If I say, okay, I am 20 years old, okay, they will say, okay, yes, you can have a license. If I go and say, okay, I'm 14 years old, they will say, no, you can't have a license yet. So that decision is based on that condition. Are you over 18 or not? So that is known as a selection structure or conditional structure. Then we have what are known as looping structures. Sometimes we want to run the program many times with different sets of values. Do the same things with different sets of values. Now, like a payroll. In the payroll calculation, we have the same algorithm for everybody. Right? Number of days you have worked, number of leave you have taken, etc., etc., etc. But for different values. So we have, if there are 100 people in your organization, we have to run the same set of instruction 100 times. So those things are used using the looping structures or the iteration. So let's take a look at these two structures. Now the first one is known as if then. That is, if a particular condition is true, then do this. Otherwise, go and do whatever comes next. Right? Now it's like this. When you go out of your house, how many of you carry an umbrella? Let me see a show of hands. How many of you can carry an umbrella? When you go out of your home, how many of you carry an umbrella? Okay, I've got, I have got, how many? I got about 1, 2, 3, 4, 5, 6 people will carry an umbrella. Okay. Oh no, so a few more. Okay, 7, 8. Right. Okay, 11 people are carrying umbrella. But how many of you carry an umbrella today? Okay. Only 4 people, 3 people. 3 people carry an umbrella, 4 people. I mean, this is a good day to carry an umbrella because there is a chance of rain. But if it was, very hot, if there's no chance of rain, many of us wouldn't carry an umbrella. Okay, I mean, I know that some girls do carry an umbrella to get the shade, but generally, if it is not raining, you don't carry an umbrella. So that is a conditional statement, right? So we have some statements that are working here. Then, right, some statements, we do these statements. And then we ask a condition. We ask a question. Is this condition true? Is it going to rain? Is this person over 18 years old? Then if that statement is true, you go and do something. Take the umbrella. If it is false, if it is not true, then you don't do anything and you go to whatever the next statement. So if it is true, you do these statements and then come to the next set of statements that come. The person who are not asking me question, can you mute please? Hello. Those who are, if you are talking to me, you can unmute and talk to me. If you are not talking to me, please mute. Okay, Ramla has asked a question and Silo has put an umbrella. Okay, good. Why are we using plus 5 instead of, no, I mean, it's not plus 5, no? Let me just give me 1 second. I mean, somebody has asked a question on the previous one. I didn't see that. Let me answer that question before I move forward. Oh, yeah. Oh, okay. So your question is this, right? Jasmine Ramla. Ramla, your question is here, is it? Hello.
Yes, sir.
Yeah, but here I am saying this variable a increase the value of variable a by 1, and then to that add 5. Now can you mute your mics if you are not asking me a question? You know, I don't want to know what you are doing in your home, so and your friends, please. You can ask any question from me, but I don't want to know what your family life is about. Okay. So here what I'm doing is, first I'm increasing the value of the variable a by 1 and adding that to 5. So that is why there are two the plus, and this plus is a single operator. This plus means this age. Very difficult to right click the mouse. Okay, is this operation age plus 1. This is what plus means. The other plus is a normal one that I'm saying add to that the value 5. Is that clear, Ramla?
Yes, sir. Yes.
Yeah.
Okay. Thank you.
Okay. Right. So let's go back to where we were. Yeah. This statement. So if this condition is true, then I will do these statements and go to the next set of statements. Then I have if then else, where I can do something for both. When the condition is true, I do something here. And when the condition is false also, I can do something else. Right? If the condition is true, I do this part. If the condition is false, I do this part. So that goes, if this condition is true, then do these things. If it is false, that means else, otherwise do these things. And then it will go here to the next set of statements. Right? Now these are very commonly used, not commonly, they are very essential structures inside the programming. Now here is a use of if then else. Right? Here you can see I have a program that has, read two values, the value 1 and the value 2. Then I go and put a statement. If value 1 equal, that means I am checking for the equality. Equal value 2, then I print a statement saying value 1 is equal to value 2. Now, if this is not true, then I go to my else statement. Otherwise, I'm checking is value 1 greater than value 2. If value 1 is greater than value 2, I print this saying value 1 is greater than value 2. Now, this also has another statement that goes with this if, right? Now, that means this is not equal, this is not greater, otherwise, say value 1 is smaller than value 2. So, this is how we use the if then else statement. In some programming statements, I will only have a if this is value 1 equals value 2, do something, but otherwise don't do anything, but go to the next statement. Okay. Right. Now Hishara has asked a question. Hishara, if marks greater than 40 print fail. No. If marks greater than 40, you can't print fail. No. If marks is greater than 40, it should be pass. No. If marks is less than or equal to 40, it should be fail. Tatsarani, are you there?
Yes, sir, I asked if marks is less than 40, print fail, or if
No.
the
That's the mark that you have put on the chat is a greater than. If marks greater than 40. If it's less than 40, it should be the other way around. In the next line is if marks less than or equal to 40, it should be the other way around. You know, if marks greater than 40, it should be pass. If less than or equal to 40, it should be fail. No, actually, it should be if marks greater than or equal to 40, it should be pass, and if marks less than 40, it should be fail. Okay.
Okay, sir. Thank you.
Right. Okay. So it fails. Right. So that is the conditional statement. Then we have iteration structures. There are two types of iteration structures. One is where we know the number of times that we are going to iterate. If I have 35 employees in my office, I will run the salary processing program for 35 people. Right? But if I go to a supermarket and that person is doing the same thing, you know, this scanning the barcode, how many times that person has to scan the barcode for a person? It is a variable value. It depends on the number of times that the number of items that the person has bought. So he has to do it until all the items are scanned. So that is what we say here. There are two looping structures. One is called while loop, right? While loop. Other one is called do while loop. These two do the same, very same thing. Now, for example, the while loop, it will come and check the condition, right? A condition, it will check a particular condition. If this condition is true, you go and do some other processing, then it will come back here and check the condition again, right? If this condition is false, it will go to the next set of statements. So this loop will run until this condition is false, right? So one thing that has to happen within these statements is that this condition has to change. For example, when you are coming here, if this condition is true and you don't do anything to change that condition, suppose this loop will run forever. That is what we call the infinite loop. And sometimes our programs go into infinite loop and they will do the same thing over and over again because we forgot to change the condition, right? Now the difference between while loop and the do while loop is when we check the condition. Now in a while loop, the moment we see while, it will check the condition, and if it is false, it will not run these statements ever. Only if the condition is true, it will go to these statements. But in a do while loop, is slightly different, where we come and do the statements and then go and check the condition. So difference between while loop and do while loop is that these statements in a while loop might not be executed at all, but in a do while loop, they will be executed at least once. Right? So that's the difference between the while loop and the do while loop. Can you mute your mic, please? I don't want to
Please,
go
please. Please mute.
තව ටිකක් ඔයගොල්ලෝ ආදරය කරන්නේවත් මේකට වැටෙනවා දැන් මේ mic mute කළේ නැත්නම්. Right, okay. Right, so this is an example. Now here I have a while loop. I define a variable called x. I put it 0 and I say while x is less than 3, right? Print before increment. Then I print. I increment the value of x by 1 and after increment. Right? So when it comes here, x equals 0, it will come and check is x less than 3. Is 0 less than 3? Yes or no? Is 0 less than 3?
Yes.
Yeah.
Yes. Okay, so this is true. Then it will go and run these statements. Then after during here, I increment the value of x by 1, so x becomes 1. After running these two statements, you go back here and check is x less than 3. Now x is 1. Is 1 less than 3?
Yes, sir.
Yes.
Yes.
So again it will run this.
Yes.
Now I increment x by 1, so it becomes 2. Is 2 less than 3?
Yeah.
Yes. Okay. So it will go and write these statements again, run these statements again, and I increment here x is equal to 3. Right? Now then I go and check is 3 less than 3?
No, loop stops.
No.
No.
Then I finish this loop. I go out of this loop and run the next statement, which is like the program is ending. Right? So that is how a while loop works. If I put do while here, do here and while at the end, this will run. Now, if I say this x is instead of 0, I say x is 4, will this loop run ever? The first time when it comes, it say while it is 4 less than 3. Is 4 less than 3?
No.
No. So this loop will be never run. Right? But if I say do loop, do, and the while goes at the end, that this statement will run at least once. Right? So that's the difference between while and do while. Then the next iteration statement is the for loop. Now for loop we call it the counter control loop. Usually we use the for loop when we know the number of times that we want to run this program. Right? Now the structure of a for loop . Somebody else asked, I'll answer that later. The for loop, there are 3 components. One is called the initialization. Other one is called the condition. The third one is called the increment. Right? And then a set of statements that I have to run. So how does this for loop work? The very first time when it comes to the for loop, first time it will run the whatever the instructions that are in the initialization component. It will run the initialization component. Then it will go and check the condition. And if the condition is true, it will go and run these statements. And after that, it will go and run the increment statement. And then it will go and check the condition. If it is true, it will run this again. Then it will go to the increment statement again, check the condition. Until this condition becomes false, it will be running this program. Right. Now, for example, let me show you. Here is a for loop. Right. I have a number here. Right. And I have a sum. Now, this number we call in the for loop this the counter. That is the one that we use to as a counter to identify the number of times that I want to run this program. Now my for loop is like this. Number equals 10. Now this is the initialization statement. Remember in our this thing I said there's an initialized statement, there's a condition and there's an increment. And then there is a set of statements here. Now here, this is the initialization. This is the initialization. So it will come and say number equals 10. Then what will it do? It will go and check the condition. Is 10 less than 100? Yes. Then it will go and now the sum is 0. To the sum, I add this number. This plus equals mean like a shorthand operation for this operation. Sum equals sum plus number. Right? That is what this plus equal means. This is just a shorthand operation for this. So it will add the number to sum. In the first instance, sum is 0. Now it started with 10. So sum will be 10. Then it goes and run the increment statement. What does the increment statement say? To number add 10. So now the number will be 20. Then it will go and check the condition. Is 20 less than 100? Yes. So it will go and add 20 to the what is in sum. Now in sum we have 10. Right? Remember the first time when we ran it, it was 10. So the sum will have 10. Right? Let me put some here. The first time I ran it, I put the value 10 there. And then go the increment statement. Number becomes 20. Is 20 less than 100? Yes. So I go and add that 20 to number. It becomes 20. No, sorry, 10 plus 20, it becomes sum becomes 30. Then I go and then the increment statement. My number becomes now it was 10, 20. The number becomes 30. Is 30 less than 100? Yes. So I add that to sum. So already there's 30 here. It becomes 60. Like that, it will go and then it will print this value also in the program. So let's just for a break, let's go and fix. So I can't write. Can you see my screen? Hello?
No, sir.
Yes, sir.
Huh?
Yes, sir, we can.
No, sir.
Somebody can't see. Are you? Okay, let me stop sharing and reshare. Okay, can you see now?
Yes, sir. No, okay.
Okay, right. Sorry, you'll have to tell me, because it must be something to do with your machine or something, Okay, so so this is the program. What time is 12 o'clock? Okay. Right. Then you can do these exercises by yourself. We might do it later. Then the third thing that I'm going to we are going to look at is something called functions. Now, for example, say you go home after the full day classes and tired, you go home and you tell your mother, Amma, can you make me a cup of tea? Right? What happens when you do that? What happens? You go and tell Ammi, can you make me a cup of tea?
She makes a tea and give me. Returns.
Yeah, so if she's in a good mood, she'll say, okay, I'll make a
Yeah.
cup of tea and yeah, otherwise you say go and make it yourself. Okay. Right. Now, what does that making tea involves? What will your mother do? You go and say, can we make a cup of tea? One simple line. But what does your mother has to do to get you that cup of tea? Can somebody tell me? Anybody who knows how to make tea, can you tell me what? If somebody comes and asks, can I have a cup of tea? What do you do?
Boiling water.
You have to go, put water into the kettle, boil it, then put some tea leaves into a jug, put the boiling water into the jug, leave it for about 2-3 minutes. Then you have to filter it. Then you have to add sugar, add milk, and then put it into a cup and bring it to you. But all those tasks were simply said in that single statement. Make me a cup of tea. Right? Now we can say that task that your mother or your sister or you perform, right, is like a function, making a cup of tea. Right? Now in C also, we have this kind of thing. We have functions. Give me 1 second because I can remember I did some. Give me 1 second, I'll bring that other slide set. Okay, here it is. Okay, so this is what happens. So you come, make me a cup of tea, and then your mother has a function called make a cup of tea that involves all these tasks, right? All this. Fill the kettle with water, switch the kettle on, wait until the water is boiling, put tea leaves into a teapot, and all that. So that when you ask, make me a cup of tea, she will run all these instructions, right? Then we'll come back with a cup of tea. Now this one, we call it a function. You see my screen, right? Hello?
Yes, sir.
Yes, sir.
Yeah. So this whole thing is what we call making a cup of tea. All these statements are part of this one, making a cup of tea. And we call this a function. Right? This is the name of a function, make a cup of tea. Right? So in C programming also, we have the same. Right? So what is the output of this function? You go and say, Ammi, can you make me a cup of tea? What is the output of this function?
Having tea.
Is a cup of tea. Right? So in programming, we call this a function, right? This is a function name. This is the definition of the function. And we say this is the return value. And this asking for a cup of tea is, we call it a function call, right? Now, sometimes you go and say, okay, say you don't like sugar. In which case, you can go and say, okay, you don't like milk. In which case you say, can you make me a cup of tea, but don't put 1 sugar and don't put milk, please. You are giving your mother some values. I don't want any milk, but only 1 sugar. Otherwise, in Sri Lanka, if you ask for a cup of tea, usually you put about 4 or 5 spoonfuls of sugar. It becomes too sweet. Because in Sri Lanka, the number of spoons of sugar that you put is a expression of, you know, how much you like that person. So if you put 1 sugar, that is you like him a little. If you put 2 sugars, that is you like him a lot, and so forth. So you have to say, okay, I want 1 sugar but no milk. And this is what we are saying. Now, when you tell Amma, okay, make me a cup of tea, she knows she doesn't have to put milk, but has to put only 1 sugar. Right? Now, in the previous case, she add 2 spoons of sugar, 2 spoons of milk. We didn't give those conditions, how many milk or how many tea. Right. So in this case, I'm saying milk and sugar, this amount, and we call these parameters. Right. I can tell this function, okay, do this task with these values. Right. So it is the same. I have the function called make me a cup of tea. Then, but on the difference is that in this time, I'm giving some parameters, 1 sugar and no milk. So your mother understand, okay, he doesn't want me to put any milk and put only 1 sugar. So he does everything except these 2, where she changes the number of spoons of milk that you put and number of spoons of sugar they milk, and but he comes out as again with a cup of tea. Okay. So this is what a function in C is. This is a very important thing, because many work that we do in functions. Right. So so in functions we have a name, right? We have a name, function name, we give it a name, and we have a return type. What kind of value will this function come back? You go and ask for your Amma, Amma, can you make me a cup of tea? What will she come out with? A cup of tea. You go and ask her, Amma, can you give me a sandwich? What will she come out with? Hello? You can tell your mother, I'm very hungry, can you make me a sandwich? What should she come out with?
Sandwich.
A sandwich, right? Right. So that is the return type. So I have to tell, I'm calling this function, and that function should return a particular type of data. And then the parameters. What kind of values should the function use to do this calculation? And then we have the what the function does statements. And finally, it will come back to whoever is calling the function with a data value. That data value should match this return type. If the data value is going to be a float, my return type should be a float. If it's going to be an integer, my return type should be an integer. If it's going to be a string, my return type should be a string. Right? So that is what a function in C is. And it's a very important, because in C, what we will do is we have the main function, and the main function will call hundreds of other functions, and those functions will call other functions. And a function will generally do something specific. Right? For example, a function can be printf. Printf is a function that is in the standard IO library. Now printf, what it can do is it can print things on the screen, and it can use the way the parameters that we are giving. Scanf is a function that can read values, and you will write your own functions also when you are writing programs. So let's see some examples. Now here is a function, and what is the function name? It's called maximum. Function name is a maximum, and I am giving it two data values. I'm giving it two data values. One is value called A, one is value called B. Right? Now inside the function, I say if I declare a variable called max, and if A is greater than B, I say max is A. Otherwise, I say max is B. Then finally, I will return this value called max. And I have declared max as integer, and my return type of my function is also integer, so there is no problem. And here is how I call that function. Right? I give the function name, and I give it two values. I give it two values, num1 and num2. So when I call this function, this A becomes num1, B becomes whatever is in num2. Now in this case, num1 is 10, num2 is 15. So when I call this function, you should call this function here, and A becomes 10 and B becomes 15, because num1 is A, num2 is B. Right? And does this calculation, and the maximum will come out, and it will be assigned to this thing called max value. Right? So this is how a function works and how we call a function. Okay, here's another example. You know, a circle area of a circle is pi r squared. So this is a function that will calculate the area of a circle. Now area of a circle cannot be an integer, so I'm saying, okay, the return type will be float. The name of the function is circle area, and only value that I need to give to calculate the area of a circle is the radius of the circle. Right? So here I am declaring the value of 5, because it's a constant, is 22 upon 7. Now that is a constant. I mean, it is we have nothing to say about it. It has been defined as 22 upon 7. Right. Then in the function, I declare a variable called area, and I say area is 5, which is the value that I have declared here to be a constant, 22 upon 7 times r. But that is how I calculate the area of a circle, and then I return that value to whoever is calling me. So in the main, I say, okay, I declare a variable called radius, which is 5. I declare a variable called area, and to area, I call this function with the value of radius, and whatever is the return by this function, I will assign it to area, and then I will print the area. So this is how we use a function. Now this is called a function call. Right? This is a function call. I am calling a function. What happens is, when I call this, it will go and find this function called circle area, and whatever value here, it will put it into this parameter and use that value to do the calculation and come back with a value for the area and assign it to this variable called area in the main thing. Okay. Any questions so far? Any questions? Hello? Anybody has any questions? No. All right. Then let's go back to our normal slide. Right. So we looked at functions, right? Then we have this thing called different data structures. Right? Now we talked about integers, we talked about floats, strings, chars, but sometimes we need to use different data structures. That is, things not are basic data types, new data type. Now, one of these very important data types is shown as arrays. Now, an array is basically a set of data values, right? For example, if I have 100 students in my class and I need to score them, record the marks of these students, one thing I can do is, for the first students, I say mark of the student 1, I can say mark of student 2, mark of student 3, mark of student 4, and so forth up to mark of student 100. I can declare 100 variables to record the marks of students, right? Like this. But it is a very inefficient way. What if I have not 100, I have, the Open University has 43,000 students. So if I have to declare 43,000 variables, I will spend a day declaring my variables. Now, in this kind of situation, we can use a structure called array. Now, in an array, we have the same name, right? Same name. Say, for example, in this case, my array. And each element in the array will be identified by an index, right? This index goes from 0 up to whatever the size of the array is. Now, in this case, my array size is 10. So it will go from 0 to 9. Only 10 elements. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. The index will be 10. Right? Now, how do I now use this? Now, I can use them as a variable. Like, for example, here I am declaring a number array that will have 10 elements, right? So what it will do is it will create my array and with 10 different variables. Now each variable will be identified by using something like this. My array and the index. When I say my array in 0, that means this value here. Right? Whatever the value is here, is index 0. If I say my array in 1, it will be this value. Sorry, this value. My array in 2 will be this value. My array in 3 will be this value. My array in 9 will be this value. And when I do this, it is just like another variable. My array 1 is just like another variable. I can do anything that I do with a variable, but how I name it is different. Right? I give it the array name and the index. So let's take a look at this example. Let's take a look at this example. Here, I'm declaring a array. I'm saying the array will be called number array, and it will have 10. It will have 10 values. Then this is a count, that is a counter I am going to use for my for loop, right? So this for loop, the initialization is count. I am saying count is 0. I have already declared the count as an integer. Count is starting from 0 until count is less than 10. Make the number array in count 0. What am I doing there? I am making all the values in my array, initializing it to 0. Right? And my condition is until the value of the count is less than 10. Make number array in count. So when it comes, it will be 0. 0 less than 10, yes. So I'll go to this statement, number array in 0 is 0. Then I go in the increment statement, increment the count by 1. So now 0 is becomes 1, 1 less than 10, yes. But now the number array in count becomes number array in 1, the first element, the second element. Like that, I will go through the entire array and make it equal to 0. Right? So let me run this program and show you. Okay. Right. You can see my screen, right? Hello.
Yes.
Yeah. Okay. So this is the program that I had. So number array I declare as a count. So instead of 0, I will initialize it to some other value, so we can see it. Let me initialize it to 100. Right. So I save the program and I run it. So you can see in this program. So here I am initializing it to 100. Then here I am printing the same value. Right? Number array in count. I'm printing count and number array in count. Right? So I will just change it. So instead of 100, I will say each number array variable will contain the count, the position, the index of that value. Yeah, you can see the location is 0. Then the value is 0. Why I'll say count times count. I will put in each array element the square of the position. When it's 0, it will be 0. When it's 1, it's 1. When it's 2, it will be 4. When it's 3, it will be 9, and so forth. Right? So you can see that it works. The first element has 0, second element has 1, third element, which is index 2, because counting starts from 0, 1, 2, 3, that has 4, the next one has 9. That is because here I said to each element in the number array, put the count times count, which is the square of the count. Right? So you can see that it works. Right. Then that's the array. So you can do many things with arrays. The advantage is that we have one single variable name, which is the array name, and I can go through the entire array by using this index. Right? So I can use a loop and array to do all type or sort of processing. Right? Okay. Then okay. Then we have different types of data, which is called the enumeration, where we start it with enum, and say that it's an enumeration type, and say working day, and I have symbolic names here. When this happens, what happens is the values, in this case, we assign value, Monday will be 0, Tuesday will be 1, Wednesday will be 2, right? It's an enumerator. Or I can even assign values. To each name, I can assign different values. And once I've done that, instead of using that value, I can, whenever I use that enumerator value, that will be that will have the same, the value that I have assigned like this here, or the default value. So we use enumeration type when we want to assign names to some integer constant. So it's like declaring a variable, right? Then again, another data type that we have in C is known as structures. Now, for example, if I have a student, right? A student has many different data, the variables. For example, a student has a name, student has an age, student has a national identity number, and either I can use them as different variables for student 1 name, student 2 name, or I can like put everything into what we call a struct. So all the data related to the student, I can put it into one single struct and use that using this dot notation. For example, here I have declared structure name, right? Struct, then the structure name, let's say student. Then the student will have a variable called name, which is a char array, character array, which is a string, and integer array called age, and character array called NIC, which has 12 characters. And here I am doing assigning, declaring 2 variables, student 1, student 2, and an array of students that has 10 elements. 3 variables I have declared. One is a variable called student 1, another one student 2, an array called S that has 10. Now, how do I access these individual variables within a struct is using this dot notation. For example, if I say student 1 dot name, that will become the name of the student 1. Dot age means age of that first student, right? So the variable will have, each variable student 1 will have a name component, an age component, and an NIC component. So how do I access each one of these components is using the dot notation. Student 1 dot name, student 1 dot age, student 1 dot NIC, and so forth. And I can, just like I work with any other variable, I can work with this dot notation, and individual variables will behave exactly like another variable, but now they will be within the structure called student. All the data related to student 1 will be there in that structure, right? Okay. Any questions? Here, this is example. I have declared a structure called student, has a name, NIC number, year of birth, and an email address, right? So this is the structure. I'm saying the structure called student has these 4 components. It has a name, it has a NIC number, it has a year of birth, and it has an email address. And that is a definition, like a variable definition is the definition. Then in my main program, I say, okay, variable student 1 is a variable of type structure called student. That is this. So the moment I do that, student 1 will be created that has these 4 components, 1, 2, 3, 4. One is name, one is number, one is NIC number, one is year of birth, one is email address. If I declare another variable called student2 of the same structure, again, it will have these 4 components. Right? And here I can see student1 dot year of birth, I assign a value. Right? Now, in strings, we don't, when we are using strings, we have to use a function called string copy. So, student1 dot name, I copy the value Anjali Khan. Student1 dot NIC number, I copy this value. Student1 dot year of birth, I assign this value. And email address, again, I assign. So, you can see that this is how I access individual elements. In this case, student1 dot name, NIC number, year of birth, and so forth. Then I can go and print. Again, I am using the same notation, the dot notation, to access individual elements. Right? Then the last thing that we have to use is pointers. Okay, 12:34. Neil, when do we finish this? It's only 2 hours, right?
Yes, sir. It is 2 hours. Yes.
Okay, but you have to give me 5 minutes so I can talk about these pointers.
Okay.
Now, a pointer is the address of a, when you say a pointer in C, that is the address of a variable. You remember we said that the variable is where we locate a value, and pointer means that where that memory location is. Now, when you use the ampersand sign, that is what we get, the location of the variable. Right? Now, when I want a variable of pointer type, I use this star mark. Right? Now here I'm saying, what I'm saying here is the P1 is a variable that will contain a pointer to an integer. Right? P1 is a variable that will contain the pointer to an integer. That means P1 will contain a memory address, and result is an integer variable. Right? So let's see what happens. So I declare these 2 variables. So now P1 will contain, is a variable that can contain an address. Right? Now result can contain an integer because it's a normal integer value. Then I can say result is 10. So value 10 will be put in a variable called result. And here in this statement, what I am saying is into P1, put the address of result. Remember, P1 we declared it as a pointer variable. Right? Pointer variable is a variable that can contain an address. And here I am saying is, get me the address where the variable result is located and put that address into pointer 1, P1 variable. Right? So these pointer variables are also very important, and it's a very efficient mechanism to work with programs. Right? Now here's an example. Here I have the result. Then I have declared a variable called P1. Result says 10. Right? Now let's run this program and I'll explain each of these statements. Okay. Now what I did was I declared a variable called P1, which is a pointer to an integer. And I declared a variable called result, which is an integer. Then I put value of 10 into result. And into that P1, which is a pointer variable, I assign the address where the result variable is. Then I am printing some values. In the first one, I'm printing the value of P1, right? Now it's a pointer variable. So the format specifier is P, right? So the first thing that it will print is here. Okay. Now first one is this. The address of result is pointer variable, and I'm printing the address of the result, which is this. In the second statement, I'm saying the value that is stored in variable P1 is this, right? Then the third one, I am saying the address of P1, right? Where the P1 is located, you can see that it's a totally different address than the previous address. So this is where the P1 variable is located. Then I can access the value of P1 either by using the variable result or using the pointer P1. Here I am saying print the value of result, and here I am saying print the value of the location that is stored in variable P1, which is the same because P1 now contains the address of result, right? So you can see that it prints the same, right? Now these pointers are a very important thing. Unfortunately, we don't have much time to work with pointers, but in your lab classes, you will be using pointers, like for example, to do SOAP2 values, etc. You will be doing this, right? Okay, sorry, I took more than extra 10 minutes. Any questions that you have to ask?
So where is this presentation is available?
Neil?
It is in the LMS. You can download from the LMS.
I think there is another.
Yes, yes, that is last year. We will upload this year presentation also.
Sir,
So is it available the recordings on the LMS?
Yes, yes, we'll do that.
Okay,
Sir.
thank you.
Yes.
sir, until now we have only accessed the learn OUSL.lk, that LMS.
Now you check whether you can access openlearn.lk, and if not,
Open
yes, openlearn.lk. If you can't log in, I will give the link to ask the question in Learn OSL as a Google form. So, okay, put that your questions to that Google form.
Sir, and also one thing, sir, for the Open Learn, how should we type the username and password?
That is also like
That Learn OSL.
username password for the students. I don't know. I will upload it to the.
Excuse me, sir. Sir, it's a S number and our ID number. Username is our S number.
S number and ID number. Right, right. Last time I think that.
Yeah, already received the email, sir.
You already received. Who not received?
Morning they have sent that.
Did someone didn't receive email?
So yesterday I am unable to attend to the meeting.
Video is available in the LMS. Open
Okay.
Lab. Yes.
Sir, do you have any books to suggest for the beginners for swimming?
All these programs are available in textbooks, and there's a reference book. It is also up. The link is available in the LMS.
Okay, thank you, sir.
Also, if you have any questions on this, you can post your questions on the LMS and we will try to answer it as quickly as we can on the subject. If you have anything, anyway, if you go to the web, there are hundreds of sites to learn how to program C. One such site is w3schools.com. You go there and it has a very simple right w3. Oops. You can find that, or if you have any questions, you can ask. My suggestion is that you start running all these programs and writing these programs and do little changes and see how it's working. And if you have any problems, contact us. We will try to answer your queries as much as we can. Thank you very much for being here till now, and good luck to you all. Goodbye. Have a nice
Thank
weekend.
you, sir.